Alrighty, boys and girls. Here we are starting the next chapter, chapter 8. And we're going to do some things a little bit different. We're going to get back into graphing, but we're going to be graphing quadratics, x squared functions. Okay? So, what does an x squared function look like? Well, it looks like this. So you see here, this is called a quadratic function. Remember function notation? We talked about a long time ago where we have this f of x equals x squared. You'll see this a lot. Remember, this is just the same thing as y equals x squared. That means the same thing. It's this function notation. This is more of a standard notation. So don't flip out when you see this. Remember, we're not solving for f. We don't divide by the number here. That's just what it looks like. So, what are some important things to note when we are talking about these shapes? Well, first off, the name of the shape is parabola. All right. You'll notice this. You should have this sketching into your notes here, and along with the rest of the stuff. So the vertex. The vertex is this point where it changes direction. So notice it is decreasing here and it is increasing here. It's going down. Even though we put arrows at the end of the line. So there's two different things going on here. One, we put the arrows at the end of the lines to indicate that it goes on forever, right? It doesn't stop. It's a line. This doesn't mean it's going up, though. When you look at this picture, when you look at these parabolas, what I need you to see, and this is important, this is actually going down till it hits the vertex, and then it's going up. All right? So when you read this graph, you should read from left to right. And this side is decreasing, this side is increasing. Now, it won't always be like that, but it will be one side or the other. All right, then the last thing, two things. One is the axis of symmetry. What does symmetry mean? Okay, yeah, same thing. It's like a mirror. It's the same thing on both sides. Notice that this parabola has symmetry. And that's going to be very helpful later when we go to graphing some of these things. So the axis of symmetry is a line right down the middle. Notice your axis of symmetry goes through the vertex. So the axis of symmetry on all these will always be an x equals some number because it's going to be a vertical line every time. So your axis of symmetry is going to look like this. Your vertex is going to be xy because it's a coordinate point. All right? And whatever x this is will always be this x here. Always, always, always. I don't say always very often. There's usually a catch. Always. So we've got our symmetry. We've got our increasing. We've got our decreasing. We've got our vertex. There's a couple more concepts we're going to talk about. But first, let's talk about where this shape came from. Why does it look like this? Well, let's do this. Let's make a table, right? Or to make function notation, let's do x and f of x. And we're going with that function we just saw, f of x equals x squared. Pick a number you want to plug in. I'll start small. Let's start with 0. If I plug it in here, what is 0 squared? Sure. So my output is 0. So that's easy. That's the point, 0, 0, right there. What is 1? If I input 1, what is 1 squared? Sure. What is 2 squared? Get 4. So if I look at these points on the graph, and this isn't a great graph, but if I go 1, 1, I'm right here. And if I go 2, 4, I'm up here. So if I look at what's going on, what's the slope from this line to this line? 1, 1. What's the slope from this point to this point? Yeah, it is 3, 1. It has a different slope. It's not a straight line. All right, let's look at the next one. What happens if I plug in 3? What's 3 squared? Yeah, 9. So 3, 9. What's the slope from here to here? Well, remember this was 2, 4, so I'm going up 5 now. Right, 1. So the slope changes. It's not a constant slope, which would be a straight line. It's changing all the time. That's why it's a curved shape. All right, well, this side makes sense. What about the other side? Well, let's plug in -1. All right, so now if I plug in -1, remember when you plug in a negative number, you need to put it in parentheses because that's -1 times -1. A negative times a negative is positive. So that would be +1. So now when I plug in -1, I get +1. So -1 is also +1. What's -2 squared? +4. If you're doing this on a calculator, you had better make sure you put that in parentheses when you hit the squared button. Because on your calculator, if you do this, it's going to tell you -1. Because the calculator is going to go 1 squared and then do the negative. Very important tip there. If you're trying to do some work on a calculator, those parentheses are important. So this is +4. So my graph goes here. Guess what -3 is? Yeah. So we already talked about the fact that it's a curve because the slope is changing. And now the negatives give positive answers. So this is where that parabola shape comes from. When you graph these, understand it's not a V, it's a curve. Don't make it a V. V is completely different. All right? So that's why your parabola, that's why your x squareds look the way they do. It's a curve, the slope is different every time, and it's got that symmetry where it's the same on both sides. So if I'm looking at this, my vertex would be 0, 0 is the vertex. The axis of symmetry. All right, so where's the middle? Now my graph's kind of off a little bit. I did this kind of sloppy, but right down through here's the middle. That's the axis of symmetry. So this would be x equals 0. I told you that number and that number will always be the same. All right, where is it decreasing? Well, it's coming down. Remember, it's got that up arrow on it because it goes on forever, but that's not really what's going on. It's going down on this side, and it's going up on this side. Read your graphs left to right. If those up arrows here are confusing to you, don't put them on. All right? This is up over here and down over here. That's what's going on with this function. So I would say it's decreasing at, x is less than 0, it's decreasing. And when x is greater than 0, all right, it's increasing. So when x is less than 0 on this side of the graph, it's decreasing. When x is greater than 0 on this side of the graph, it's increasing. Okay? Make sure you're writing all this down. So, what else do we got? Okay, so these, we talked about something a long time ago. We talked about domain and range. All right, domain is the x's that you can plug in. Range is the y's you can get out. So, one more thing to talk about here. What possible x's could I plug in here? Well, I could plug in anything. All right? All range. Any x could get out. What possible y's could I get out? Well, I can't get all of them, because if I look, this curve never comes down here. Right? There's no curve down here. So if I look at my range, it starts here and goes up. So my range is everything greater than or equal to 0. So my x's, I could plug in anything. Like I said, This goes on forever and ever and ever. It'll take a while to get over there, but I can plug in 345 and do 345 squared and get some gigantic number that's up, at the moon. But I can plug in anything. My domain can be any number. What is the output? What is the range? Well, my range could be equal to 0 or greater than 0, but it'll never be less than 0 on this graph. All right, let's take another look. So let's take a look at this function here. Consider this graph. Identify the characteristics such as the vertex. So what is the vertex? Well, right here, it says the vertex. This is the point where it changes direction. So here's the axes. So the vertex is right there at -1, -2. Any questions on that? Axis of symmetry, we said that's that line. It'll always be x equal a number. That number will always match the number in the vertex. So this line right here is my axis of symmetry. X equals -1, that vertical line right there. All right, so what is the domain? Well, domain is all real numbers. I can plug in any x. What is the range here? Well, what are the possible output values? What are the possible answers for y? Any thoughts? Oh, let me get out of here. It's on the board. All right. So here is the bottom of my function. It's going to be anywhere up here. So I would say the range greater than or equal to -2. Because right here at -2 is the bottom value of my function. It could be higher. That's where the graph lives. It will not live below that line. Notice there's a connection from your range and your vertex, that y coordinate of your vertex. There's a connection. All right, so we've got all of those. Now, let's talk about increasing, decreasing. Where is the function decreasing? So here's my axis of symmetry. It's decreasing on the left, but we don't say on the left, all right? What we say is from here less than. So x less than -1 is decreasing. From here, this side. So this is where it's coming down. When x is greater than -1, it's increasing. From here, this way. Right at -1, it's not doing anything. It's right there. It's flat. It's just a single point here. So it's decreasing up to -1 and increasing when you get past -1. Notice again the connection. This number here, you're increasing and decreasing your inflection point. That's going to be the same number as the axis of symmetry, and it's also the same number as the x-coordinate of your vertex. There's going to be relations here. This shouldn't be a guessing game. Once you start to see this vertex, you can fill in some of these things. You just need to figure out if it's increasing less than or greater than as we take a look at the function. All right, so that is the big overview. Now let's talk about some other things. So see if you can tell me. I want you to tell me the vertex, axis of symmetry, where is it increasing, where is it decreasing, and what else? Oh, domain, and range. Tell me all of that for these two functions. Here we go. Where's the vertex? To -3. Where's the axis of symmetry? Once you know that, I know My axis of symmetry, always the same numbers. Where is it increasing? Well, it's increasing greater than the vertex. It's decreasing less than the vertex. Okay, the vertex is that pivot point. What's the domain? Always gonna be all reals. What's the range? So here's the bottom. It's going up above that, greater than or equal to -3. All right. Number 2, where's the vertex? Axis of symmetry. Increasing. Well, this one is increasing here. This is where it's going up and coming back down. So it's increasing less than -3 this side. It's decreasing greater than -3. All right. Domain. All reals. What's the range? Well, this one is upside down, so the function lives down here. So the function's got a highest point right here, and the function lives below, so it's y less than or equal to 7. Any questions about any of these values before we move on? All right. So let's talk about how we actually create these graphs. So where everything's not just a plane x squared. By the way, these would not be created by plane x squared. There's a lot going on here. We'll get to all of it. So, how would you graph it? Well, this is a little confusing to be honest with you. So, I want to show you this. So here's a plane x squared. This is what we talked about earlier when we plotted those points. Notice I've got points here, right, at 1, 1. I got a point at 2, 4. I got a point at 3, 9. Right, I got a point at 4, 16. So this right here is my main one. And I've got this point here, right there. So I've got all those points that we talked about with that table earlier. So what happens when I put a number in front of the x squared? Because that's what we're going to talk about today. That's all we're talking about today. What happens if I put a number in front of x squared? So I got this slider here. So watch what happens. So right now the number in front of x squared is 1. Watch what happens when I take it up to 2. What's going on with my graph? You see it moving? What's going on when I take that number in front of x squared and I make it a big number? So let's make it 6. So what's going on? Yeah, it's getting skinny. The technical thing of what's going on here is it's being stretched. So I took this original function and I'm stretching it. Because now look, 1, instead of being right here, 1 hits at 6. 2 doesn't hit at 4, 2 hits way up there. All right, so it's being stretched 6 times its normal. So it looks skinnier, but what's actually going on is it's being stretched. It's a little easier to see if I dial this back down to 2. You can see the stretch. So this, instead of being at 1, is stretched up to 2. Instead of being here, is stretched up to 8. Instead of being here, is stretched, and I'm a little bit off, but it hits right here at 18. So I'm taking the normal curve and I'm stretching it, I'm doubling it. So whenever you put a number in front of the x squared, a whole number, something bigger than 1, it stretches it. So what happens if I take something less than 1? Well, let's take this down and go, let's go about a half. All right, look, it's out here. It moved outside. Well, why? Well, now instead of being at 1, it's at a half. Instead of this being at 4, it's at 2. Instead of this being at 9, it hits at 4 1/2. Okay, I'm kind of squishing it. All right? So multiplying it by 1/2, putting a 1/2 in front of your x squared has an effect of kind of broadening it. It's a little hard to play with because I got to liberate it, but you can see it's outside the normal right there. So take it to 0. So you can see, if I got a big number here, I'm stretched. If I'm at 1, I'm at the normal. If I got less than 1, I'm living here. What happens if I go negative? Yeah, it's going to flip upside down. Look at it down there. So negative does the same thing. Negative less than 1. So I'm looking at negative 0.7. It's skinnier than normal, or it's wider than normal because it's less than 1, but it's upside down. If I go to negative 4, negative 5, it's skinnier than normal and it's upside down. All right? So, let's talk about how we can graph these. So you see you got the positives, you got greater than 1, squeezes, less than 1, widens, negative, flips. So, graph this compared to the graph of that. So what they want you to do here, right now all we have is a table. I've got 1, 1, 2, 4, 3, 9. Sketch that. You'll get real good at sketching the original graph, the parent function. All right, sketch that. 2x squared. So, double your output. 4 goes to 8. Double it. 4 goes to 8. And sketch that. Notice 0, 0 didn't change, because if I double 0, I still get 0. Yeah. So I took it 2 times, so everything got stretched by 2. All my y's got stretched. It stretched it way up there. Okay. Mathematically, if you want to put them into your calculator, sure. What happens when I put in, this is g of x, sorry. I put in 2. 2 squared is 4. 4 times 2 is 8. You can punch them into your calculator if you want. It'll be faster if you just understand what this is doing. Then you can just look at the parent and stretch or squash if you need to. So, right here, again, I've got the parent function. Zero, 0, 3, 9, negative 3, 9. You'll get real good at sketching that parent function out, all right? So, I have this graph. What is going on if I put a negative 1/3 in front of that graph? How is it going to affect the parent function? So, first thing I want to look at, it's going to flip it. Taking those, and I'm flipped down there from the negative. Now it's going to be 1/3. So instead of being 1, 1, it's going to be 1, 1/3. Instead of being 3, 9, it's going to be 3, 3. So now I don't have these points here, and I've got a function that looks more like that. And obviously on your paper with the graph paper, it'll be a whole lot easier to see, and mine gets a little sloppy if you're on the board. Obviously on big ideas, it'll be a whole lot easier also. But that's the idea. You identify the parent function. It would be helpful if you would sketch it lightly every time. Don't try to do it in your head. And then you see how this number in front affects it. It's either going to stretch it, squash it. If it's negative, it'll flip it. All right. So let's do a couple of these. Let's do 6 and do 5. Sketch those. So I'm gonna do this one in red. Okay, so my normal would be 1, 1, -3, so it's gonna go upside down and it's gonna stretch by 3. So instead of being here, it's gonna be here. And I know that's 10, so instead of being 4, it's gonna be at 12. So your function should look something like that. What's this gonna do? Well, is that number bigger than 1 or smaller than 1? Okay, bigger than 1. So I know it's going to give me a stretch of some sort. Calculators will come in handy here. So instead of being 1, 1, I'm going to be at 1 and 1.5. Instead of being at 2, 4, 4 times this is going to be 6. So it's just going to give me a slight stretch. And I know from my symmetry, this one's going to be at the same spot. So I know it's going to be slightly stretched from the original. All right, again, on graph paper and on the computer, it's going to be a whole lot easier. But I just take this number. If you have a hard time seeing these in your head, you can always go to a calculator. But all I'm doing here is I know that my original, if I plug in 1, I get 1. I'm just taking that times 3.2, times 3 over 2, sorry. I know if I plug in 2, I get 4. So I'm taking this and multiplying by 3 over 2 to get 6. That's all I'm doing, I'm just doing it in my head. Okay? And then I know from symmetry, if I plug in -2, I also get 4, so that's also going to be 6. So that's all I'm doing, is I'm remembering the original that we talked about with the tables, and then just taking it and multiplying it by that number to see how it gets adjusted. All right, there you go. We will talk tomorrow about how we can change the vertex. Vertex isn't changing today. Good luck, get to work, ask questions.